Hello students, this is exercise 4.3 and the first problem is find the nature of the roots of the following quadratic equations. If the real roots exist, find them. So let's start with the first one. 2x squared minus 3x plus 5 equals 0. And to find the nature of the roots, we have to first find the value of d or discriminant. So what is the formula for discriminant? D equals b squared minus 4ac. And here a equals 2, b equals -3 and c equals 5. So using these values we'll find the value of d. So therefore d equals -3 the whole squared minus 4 times 2 times 5. This is 9 minus 40 and this is equal to -36. From value of d we can determine the nature of the roots. So we'll write it. If d is less than 0, no real roots exist. If d equals 0, we'll have two equal roots. If d is greater than 0, two distinct real roots exist. So we know these conditions, and based on that we can say since, and based on this we can say since d is less than 0, no real roots exist. This is the answer for the first one. Now let's move on to the second one. 3x squared minus 4 root 3x plus 4 equals 0. A equals 3, b equals -4 root 3 and c equals 4. And we know the formula for d. D equals b squared minus 4ac, and we'll substitute the values. This is -4 root 3 the whole squared minus 4 times 3 times 4. So this is 48 minus 4 3 is a 12, 12 4 is a 48, 48 minus 48. So this is equal to 0. We can write since d equals 0, we'll have two equal roots exist. Okay, now we'll find the value of the roots. We have the formula x equals -b plus or minus square root of b square minus 4ac whole divided by 2a, and this is minus of -4 root 3 plus or minus square root of, and we know the value for b square minus 4ac because just now we found it. It's 0, so we can directly substitute that. 0 by 2 times 3. Now let's continue this. So that is equal to 4 root 3 over 2 times 3, and we can cancel this. 2 will go 2 times, root 3 will go root 3 times. So the roots are 2 by root 3 and 2 by root 3 because we have two equal roots. So this is the answer for the second one. So we can even write it as x equals. Now let's move on to the third one. 2x squared minus 6x plus 3 equals 0. A equals 2, b equals -6 and c equals 3, and we know the formula for d. D equals b squared minus 4ac, and let's substitute the values. -6 squared minus 4 times 2 times 3, this is 36 minus 24, that is equal to 12, and since d is greater than 0, two distinct real roots exist. So we're going to find that x equals minus b plus or minus square root of b squared minus 4ac whole divided by 2a, and again we'll substitute the values. Minus of minus 6 plus or minus square root of, and we know the value of b square minus 4ac, this is 12 because we have already found that. So square root of 12 over 2 times 2. So this is equal to 6 plus or minus square root of 12, we can write it as 4 times 3 over 4. Now this is equal to 6 plus or minus 2 root 3 over 4, and in the numerator we can take 2 commonly outside the expression. So this will be 2 times 3 plus or minus root 3 over 4. We can cancel 2 will go 2 times. So the roots are 3 plus root 3 over 2 and 3 minus root 3 over 2. So this is our answer. Now let's move on to the second problem. Find the values of k for each of the following quadratic equations so that they have two equal roots. And we know the condition for two equal roots. For two equal roots, the value of discriminant d is equal to 0. So we have to find the value of d first and equate it to 0 to find the value of k. So let's start with the first one. 2x squared plus kx plus 3 equals 0. Here a equals 2, b equals k, and c equals 3. Now what is the formula for d? d equals b squared minus 4ac. So we'll substitute the values. This is k squared minus 4 times 2 times 3. So this is k squared minus 24. Since two equal roots exist, d equals 0. So we're going to use this condition. Therefore, k squared minus 24 equals 0, or k squared equals 24, or k equals plus or minus square root of 24. This is equal to plus or minus square root of 4 times 6, that is equal to plus or minus 2 root 6. So k can take two possible values. K equals plus or minus 2 root 6. So this is the answer for the first one. Now let's move on to the second one. Kx times x minus 2 plus 6 equals 0. So let's simplify this and bring it to the form ax squared plus bx plus c equals 0. So we'll just expand this. Kx squared minus 2kx plus 6 equals 0. Now a equals k, b equals negative 2k, and c equals 6. Now what is the formula for d? d equals b squared minus 4ac. So that is equal to minus 2k the whole squared minus 4 times k times 6. So this is 4k squared minus 24k. Since two equal roots exist, d equals 0. Therefore 4k squared minus 24k equals 0. We can take 4k outside. K minus 6 equals 0. So either k equal to 0 or k equals 6. But we have to discard or reject k equals 0, because in a quadratic equation of the form ax squared plus bx plus c equals 0, a is not equal to 0. This is the condition for quadratic equation. So a should not be 0. Here we have k as a, therefore k cannot be 0. Rejecting k equal to 0, we have k equals 6 as the answer. So that's about it.